Good morning, students. Today we are going to be on section 8.1, and we are going to be working with right triangle trigonometry. So we are doing right triangle trig ratios. We're doing right triangle trig ratios, and ratio is just a fancy word for fraction. Okay, so what we're going to do is we're going to define 6 trig ratios and see how to use them, and then we're going to use them. So you're going to have 2 rows. So leave your notes so that you have 2 rows so you can line up 2 definitions, 2 definitions, and 2 definitions. So define the following 6 trig ratios. Okay, what we're going to do is we're going to use this triangle right here. So we have a right triangle, and we're going to start right here. And that symbol is the theta symbol, and what that means is angle. So that theta symbol means angle. Okay. And now, if we look at this theta symbol, first of all, for a triangle, we have 2 legs and a hypotenuse. The hypotenuse is the longest one, right? So we'll say hypotenuse. So the longest one of the triangle is the hypotenuse. And then from this angle, we have the 2 legs. From this angle, we have the opposite leg, and then we have the adjacent leg. The adjacent leg is touching the angle, and the opposite leg is the opposite side of that angle. So when you have an angle given or you pick an angle, then you have an opposite leg, an adjacent leg, and you have a hypotenuse. So we're going to be dealing with those as we set up our ratios. So our first ratio is going to be sine. And sine is abbreviated as SIN. And sine of an angle equals opposite over hypotenuse. Equals opposite over hypotenuse. Okay? And leave some space over here because we're going to do something that goes with sine. Then we have cosine. And its abbreviation is COS. So the cosine of theta, or the cosine of an angle, is adjacent over hypotenuse. And then you have tangent. Our third one is tangent. And its abbreviation is tan. And tangent is opposite over adjacent. Okay? And then what we're going to do is we're going to have some that go with it. So essentially the opposite of sine is called cosecant. And cosecant equals 1 over sine. Or cosecant is hypotenuse over opposite. Right? So it's just flipped. Hypotenuse. So cosecant is hypotenuse over opposite, and sine is opposite over hypotenuse. So this is the opposite of this. And then for cosine, the opposite is secant, which I could say is 1 over cosine, or we could just write it as hypotenuse over adjacent. And then we have cotangent, which is adjacent over opposite. Adjacent over opposite. Okay, so there are your six trig ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Okay, now how do we use those in our math? So this, you're going to use this the whole lesson. So have this somewhere where you can see it. Example number 1. So given triangle ABC, which I'll draw in a second, find all 6 ratios for angle B. Okay, so here's our triangle. We have, this is B, C, A, and we have 3, 4, 5. Okay, now we're working from angle B. So we're getting all our measurements from angle B. So here's angle B. So this is our theta. This is the angle that we're working with. So from here, this is our hypotenuse. From here, this is our adjacent. And from here, this is our opposite. So please label in every problem that you do today, please label from theta what's your hypotenuse, what's your opposite, and what's your adjacent. And this is the reason you label it, because sine is opposite over hypotenuse. So sine of B equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. So cosine B is adjacent over hypotenuse. Tangent equals opposite over adjacent. So tangent B, tangent from this angle, is opposite, which is 4, over adjacent, which is 3. So there's your 3. And then the easiest thing, cosecant is the opposite of sine. So cosecant B equals 5 over 4. It's just the opposite. Secant B equals 5 over 3. And then cotangent B equals 3 over 4. Right? It's just the opposite, reciprocal of this, reciprocal of this, reciprocal of that. So there's your 6 ratios for angle B. All right. Example number 2. Sine for theta is 5 over 13. Find the other 5 trig ratios. Find the other 5 trig ratios. So I'm just going to draw my triangle. I don't know exactly what it looks like. The only thing I do know is that it has to have a right triangle. It has to have a right angle, because these trig ratios only work with right triangles. And so I'm going to pick an angle that I'm going from. So I'm just going to pick this as my theta. This is my angle. So this is my hypotenuse, this is my opposite, and this is my adjacent. This is theta, this is my hypotenuse, this is the opposite angle, this is my adjacent. So sine equals, when I look back here, opposite over hypotenuse, opposite over hypotenuse. So 5 is my opposite, 13 is my hypotenuse, So what's my adjacent? Because I need my adjacent if I'm going to do all 5 trig things. Well, this is going back. You're going to have to do the Pythagorean theorem to find this side. So the steps for finding this, first is you draw triangle, draw or build, and input what you know. And then second is Pythagorean theorem. And if you remember, that's a squared plus b squared equals c squared, or leg squared plus leg squared equals c squared. So we have 5 squared plus b squared equals 13 squared. So 25 plus b squared equals 169. How do I solve that? We'll take 25 off of both sides. We have b squared equals 144. How do we solve? Because we just want b, not b squared. So we're going to square root both sides. And we get b equals 12. So this side, our unknown, is 12. Awesome. Now what we're going to do, I'm going to bring in my old notes so I can see. So sine is opposite over hypotenuse. We already have sine is 5 over 13. And then we have cosine for theta equals adjacent over hypotenuse. So 12 over 13. And tangent of theta equals opposite over adjacent, 5 over 12. And then we do the opposite. Cosecant equals 13 over 5. Secant equals 13 over 12. And cotangent equals 12 over 5. So there are our six ratios. All right. Now we're going to use some of this trigonometry to find some unknowns. Example number 3. Find the value of x. So here is triangle, and you have 10, you have x, you have 35. So theta equals 35 degrees. So that's a 35 right there. So let's see which, from this angle, from theta, we have opposite, we have adjacent, and we have hypotenuse. So it looks like we have adjacent and hypotenuse. So for adjacent, so if we look up here, adjacent hypotenuse, right here, we have cosine. So we're going to go cosine of this angle, 35, equals adjacent over hypotenuse. So cosine for theta equals adjacent over hypotenuse. So we see here, we have adjacent is x, hypotenuse is 10. So you have cosine 35 equals x over 10. How do we solve that? Well, let's get our x by itself. So we multiply this side by 10, we multiply this side by 10. So we now have 10 times cosine 35 equals x. Now, I need you to be careful because I'm going to show you two calculators. So this the length of something can't be a negative number. Can't be a negative number. So unfortunately, if I put into this calculator cosine of 35, I get a negative number. In fact, if I put 10, oops, the best way to do this would be just to put 10 cosine 35, just to plug this in the calculator, and I should get my length of x. Unfortunately, this gives me a negative number. So if you're coming up with a negative number, we need to reset something in here. Because if we look, cosine of 35 is actually a positive number. And if I plug in 10 times the cosine, 10 times cosine 35, I get 8.19, so 8.2. The hypotenuse is 10. This leg being 8.2, that sounds pretty legit. So that is, in fact, our answer is 8.2. So our x equals 8.2. So if the calculator is pulling up negative numbers, trade it out, and I'll figure out how to reset the calculator so that they get appropriate numbers. Now, if you want to use your phone, you can go to the calculator, and what you can do is we'll put in 35 cosine, we get a number, and then we multiply that number. For this problem, we multiply it by 10, and we get 8.2. So again, you would just put in the angle value, cosine, and then you multiply it by 10, and it would give you 8.2. So that's how you can use your phone for these also. All right, last example. Example number 4. Example number 4. Find the value of x. So here, we've got another triangle. Again, it's a right triangle, and this angle is 50. This is x, and this is 12. So your angle, or your theta, is 50 degrees. Now, from this angle, we have adjacent, we have opposite, and we have hypotenuse. So what we want is we want something that deals with hypotenuse and opposite. So which one of our 6 deals with hypotenuse and opposite? Right here. Sine of theta equals opposite over hypotenuse. So sine of theta equals opposite over hypotenuse. All right, so how do I set this up? Well, my theta is 50, right? That's the angle that I'm working with. It's 50. The opposite is 12, and my hypotenuse is x. Opposite is 12, my hypotenuse is x. Now, how do we get x by itself here? Well, the interesting way to get x by itself, what you're going to do is you're going to multiply both sides by x. So now I have x times sine of 50 equals 12. But we just moved the x. What we have to do now is we have to divide by sine of 50. So that cancels out, and you have x equals 12 divided by sine of 50. Okay? If you have a calculator that works, you can simply put in 12 divided by sine 50, and you get 15.66. Well, that's 12. Hypotenuse is longer. 15.6, that looks legit. So x equals 15.66. Now, how would you do it in your phone? Well, a little bit more difficult, but let's check. So on your phone, we would go 12 divided by, and then to do sine here, we would go 50 sine, 15.66. So if you saw that first number, it just shows you what sine of 50 is. So 12 divided by 50 sine is 0.76, gets you 15.66. So that's how you can do it in your phone. All right, your homework for tonight, page 225, numbers 1 through 6. Let me know if you have any questions. All right, enjoy.